Oh, well, I took a picture of it. I don't know. Wait, is it up here? Yeah, it's right here. Question 36.
Oh, I had that one too.
I was trying to like look it up to see how to do it, but I don't even know how to like set it up. I don't even know.
Okay, so let's think about it, right? So if we're doing a reaction here, I'm going to write it on your screen if that's okay.
Yep.
So reaction between these two combinations, right? So then we have sodium is gonna go with chlorine, and ammonium is gonna go with nitrate, right?
Yes.
Okay. Now this is an aqueous solution, right?
Mm-hmm.
Okay. So these guys are going to be breaking up into their ionic components. On the other side, if these guys react, they're also going to be breaking up into their ionic components. You're going to have sodium chloride, AQ. Is that correct?
Mm-hmm.
And ammonium nitrate, AQ. So if we looked at the total ionic equation or the net ionic equation, there's not going to be anything left because everything is a spectator, right? So these guys are all going to be broken down into Na plus AQ plus NO3 minus AQ.
And we know that from the solubility table, right?
That is correct.
Okay. Okay, that makes sense.
That's like when it says NR, right? At the end. Like on our homework, it had those problems too.
That's right. That's exactly it. It's the same thing as NR. That's right, Cheyenne. Perfect.
Okay.
Yeah.
Thank you.
Yeah. That means that there's no reaction because there's nothing going to react. You're not getting a precipitant. You're not making any gases. You're not making any liquids or anything like that. All you're getting is all of these ions in solution that are not doing anything with each other.
Oh, okay.
Aqueous, right? Like none of them are gases, solids.
That's right. Exactly.
Okay.
Yeah. That's why I love this question. Beautiful question.
Okay, thank you.
Okay. She didn't even let me finish writing. Next question.
Oh, sorry. I thought you were done.
Next question. Oh, there's only 6 of you guys.
Yeah. Can you give us an example of what you're going to have in terms of solutions? Like
Sure.
kind of the concept of the question at least.
Were you the one that texted me about the solution questions?
Yeah, trying to get us out of it, but you told me no.
He was trying to get the answers for the quiz.
Nah.
It'll be something like this. I'll give you guys since you guys came.
You get the exclusive sneak peek.
That's right.
Ooh.
C1 B1 equals C2 B2.
So it'll be a normality question
It'll be
or concentration.
Probably a molarity question. Normality doesn't come into play a lot of times. We kind of avoid it for the most part as scientists because it was something that was done a long time ago and it talked about equivalencies and shit like that. It'll probably be molarity. Molarity is capital M with the line underneath. It's the abbreviation for molarity. Molarity. So obviously it has something to do with the mole, right? Molarity is equals moles over liters. Okay. Now, the beauty of molarities is moles over liters. It's moles of solute. Do you remember what a solute is? We've talked about it before.
We had a discussion on it too.
Isn't it a
Reduce of
substance
solution.
that dissolves into the solvent?
That's right. And what is the solution?
It's a mixture of the solute and the solvent.
That is correct. Okay, so the solution is everything, right? And the solute is just what you're dissolving in the solvent. Okay. Okay, so that's molarity. Okay, so in most cases, you're probably going to have a question that deals with molarity, because that's what you're going to most likely come into contact with, or percent mass, which you guys already know. Okay, so both cases are examples of concentrations, right? So C represents concentration, V represents volume. So C represents the concentration that you're starting off at, and V1 would be the volume that you're starting off at. C2 would be the concentration that you're going to, and V2 would be the concentration that you're getting. So for instance, if I tell you we're going to make a solution from our stock solution, which is 1 molar, that's moles per liter. And we want to make a, let's say 500 mils of a 0.1 molar solution. How many mils of our stock will we need? Okay, so then you'd use this equation. This is your V1, this is your V2. This is your C2. So then all you need to do is solve for V1. So then you get V1 equals C2 V2 over C2, C1 instead of V1. That's making stuff up. Okay, so it's just plug and chug. Pretty simple.
Yeah.
Yes.
Okay, so concentration could be in terms of molarity. It could also be in terms of percent mass. So be familiar with most. If it's percent mass, then you'd have percent mass over percent mass, then you're going to be okay. As long as your volume units are exactly the same, then you're going to be okay. Okay. I feel a little bit better, Jason. You're not gonna go jump off a bridge or anything?
I thought about it last night. You had me stressed out.
So you're not the one that texted me at 12 in the morning, were you?
No, I go to bed earlier than that.
What
Can't
was
stay
that,
up that late.
Vanessa?
No, it wasn't Dr. Henry. Or it might have been one day.
And don't even save our numbers, huh?
I have your numbers, but I haven't put your names next to them. I'm working on that because there's a lot of you, and you guys are, it's only for the semester, so I figure I'll never get another call from you guys ever again.
I don't know. I might call you and go, hey, I have this question in general, Ken. How do I do it? I know you're up until 3 in the morning.
Right.
He wakes up at 3 in the morning.
Oh, true.
Yes, not at midnight. Usually I'm in a deep snoring state at that point. Okay, any other questions?
Let me see.
Boy,
Yeah,
this is
well,
the
you didn't-
easiest
You
review
didn't
I've ever
announce
done.
who's you didn't announce who's getting extra credit for exam 3.
Oh yeah.
Oh, I didn't announce, I'm sorry.
And
They'll
then
know it. I'll send an email telling you who it was.
okay. And then the people that score the highest on exam 3, do they get extra credit on the final, or it's just for exams?
The way the final works, if you were in the top 6 for all 3 exams, you get extra credit.
Damn. So Kevin's probably gonna get extra credit then.
He's so stressed about like failing it, but I'm just like, dude, you're
You
fine.
get like the best grade in the class.
I know.
Oh my god, that's funny.
I just want to play a gag on him so bad. But he'd probably hurt
Yeah,
himself.
Yeah, I think he'd be. I don't think he would take it well.
No,
I don't think he
don't
would find it funny.
at all. At all.
Oh, and do I need to text you to remind you to look at, do you know, like last Wednesday we found out that I uploaded the extra credit in the wrong place?
Yes. You still need to text me because I totally forgot about it.
Yeah.
Yeah.
I will do that today.
Yeah.
And
Make sure you include who you are, because he doesn't save your number.
yes, I will. Does anybody else have a question? Because I already asked one.
Yeah, I have a question about is it delta H? Is that how you say it?
I was going to ask about that. Thank you.
Yeah. No problem. Enthalpy. Yes. I'm looking for my notes about it. I just always, I know I talked to Jason about it, but I just want to be certain when it comes to seeing a negative in the enthalpy and a positive and how it relates to the reaction.
Sure.
Is it the question that had the negative 185 kilojoules? Is that the one that you're talking?
I don't know if it's that specific question, but I just know that I'm confused on that.
It would be the same concept.
Okay.
Yeah.
So tell me, enthalpy. So what do you think the negative means?
Isn't it that it's whether it's releasing or gaining energy, basically? I think it means that it's endothermic, I think.
That is right, Cheyenne. So if it's positive, right? Positive means you're putting something into it. If it's negative, that means that something is being released from it. It's being let go. Okay?
Got it. So if it's negative, it's exothermic. If it's positive, it's endothermic.
That is correct.
Okay. Okay.
I love it when you guys translate to scientific terms. That's beautiful. That means you guys actually did learn something in my class. Stop laughing. Now you make me worried now.
The practice model made me feel like I didn't learn anything. I was like, where did it all go?
Hey, Dr. Henry. Are we gonna know when your tutors will be available?
I am trying to get that finalized right now as we speak.
Oh.
I just sent them a text and I'm waiting for them to get back to me. But they all agreed to give you a well, I love it. They all agreed to give you a day, but they just haven't given me the day. So
It's
Can
gonna
you
be
go over the open-end manometer again?
sure.
I think when we were doing our quick lecture, I kind of scribbled my notes a little too sloppy.
You mean all your tutors will have one day, or we only have one day of review?
Well, you have me, of course, here, today, and then no, I can't guarantee that they all will have one day, but they will have at least an hour of review.
Oh.
Before your final. So So let's start with an open-ended manometer. Excuse my drawings here.
It's a pretty good drawing for using a mouse.
Spoke too soon. Okay, that's my gas in here. Okay, so if our manometer, this is my mercury, does this, say, so the blue line represents the mercury going up in that direction. Let's assume that it goes up 120 millimeters. So what is the pressure of the gas?
Is it the 120?
No, it's not going to be 120. Why isn't it going to be 120? 120 is just the distance between here and here. So what else do I need to add on to it to get the complete pressure of the gas? Now, which way is the gas push?
760.
The atmospheric
760,
pressure?
that's right. So I need to add 1 atmosphere, which is 760, plus 120.
Oh, I see.
Is that because the mercury is going, is it traveling up out of the spout?
Yes, it's traveling.
Okay,
it's not traveling
I think,
out of the spout, but it's traveling.
but up.
Is traveling up, exactly. So
I
the
think that's
pressure
why
of
I
the
mixed
gas,
myself
that
up.
means, yeah, so that means that the pressure on the inside is greater than atmospheric pressure. So this
Okay.
represents atmospheric pressure, 760. Yes, some good questions. And then this is just that change. And so we know that it's 760 millimeters of mercury. So then it's be 860 millimeters of mercury. Hey, you made me want to change my question that I put on the exam.
No, you should just leave
For
it.
this
Cut
one?
us some slack.
Go
Cut
ahead.
us some slack. We only learned it a week ago.
What was that?
I said, cut us some slack. We only learned it a week ago.
Barely.
Okay. So then if the mercury goes the other way, that's when we subtract it, right?
That
When it
is
goes
correct.
Towards the flask? Okay. I think
Yeah,
I had it
so-
written backwards, so I was
Yeah.
confused.
Wait, but how did you know that it went like upwards instead of down?
Because think about it logistically, right? So if the gas is pressure, if it's strong here, it's going to push the mercury higher on this side.
Oh,
If the atmosphere
I
is
see.
stronger, then it's going to push it the other way.
Oh, okay, I see. Okay.
Yeah.
Thank you.
I was a kid. When I was a kid, I used to take straws and hook them together and stuff like that. And then I put liquid on one side and then, or put liquid in it, and then I blow it out at my sisters, you know? So I always knew that if I put more pressure on this side, you know, but if there's more pressure on the other side, then it's great.
Would this be considered like a exothermic reaction, like a negative enthalpy?
That is a good question. So this is based on pressure, right?
Oh.
Okay, so we're talking about pressure here. We're not talking about enthalpy here, but enthalpy is a combination of its heat of the reaction, but pressure can play a part in it as well too.
Right.
So chances are, because there's pressure being put on the system, so it'll be P delta V, usually a change in volume is usually the work that's associated with it. And that's going to be part of that reaction as well too. So in a sense, it can play a part into it, but that's only if you want to make it more complicated. We haven't talked about that yet, but since you're bringing it up, you know, we could talk about it and I could put it on the test too.
No, it's okay.
It's okay?
I feel like there's a lot of threats going on.
Threats? There's no threats. There's no threats going on at all. It's just you guys are making me aware that God, you guys are asking such good questions. So maybe the questions I have on the exams are not challenging enough for you.
It took me the whole 2 hours.
I guess you really want me to
bucket,
fail the exam then.
The better we do, the better you look. Let's just remember that.
Okay.
And the better that I'll feel too.
So win-win-win all around.
Yeah, but I don't want to disappoint you guys. You know, I don't want it to be too simple.
No,
It
it's
could
not
never be
too
too
simple. Yeah.
Any other questions?
I had another question. This is kind of off topic, but will you be reviewing again on Wednesday, or is this the last one for you?
This will be, no. So I have one tonight at 5.
Oh, at 5?
Yeah, I'll send you guys the link.
Okay.
I have one tomorrow at 9:30.
Oh, okay, great.
Can you go over STP again?
Yep.
We had a question for the volume of STP and I was kind of stumped on it.
Okay.
And regarding that, you always want us to use Kelvin, right?
That is
Never,
correct.
never like Celsius or Fahrenheit.
That's right.
Okay. And if we did happen to use Celsius, we'd get the total wrong answer.
That's right.
Okay, just making sure.
What I saw for a problem on the practice exam that I looked up is like the person, even though the question was in Celsius, we're supposed to convert it to Kelvin for the problem and then convert it back to Celsius to get the answer, which I found interesting.
Okay. You have one like that on your practice? That's just because I want to, you know, challenge you guys to make sure that you guys understand Celsius and Kelvin are not the same.
Yeah. I just never would have thought to have like because if it's Celsius in the question and the answer is supposed to be in Celsius, then I didn't think that I would need to change it to Kelvin, but I did.
Okay. So I'm sorry, got lost. What was the question again, Vanessa? Wasn't Vanessa, you had a question that was off topic?
Oh, it was I already asked it. You want me to ask it again?
Did I answer it?
Yes.
Okay, good.
I think Jason was asking about STP.
STP, that's what it was. STP, sorry. Standard temperature, and pressure. I don't know what I'm thinking today. Temp and pressure. Okay. So what is STP? What are the values?
1 bar,
So,
0 degrees Celsius. But then you have to change it to Kelvin, right?
That's right. Which is just
What is
273.
it? 273. Yeah.
Okay. Okay. So more than likely, you probably got a question like,
it asks for the volume of, let me find it again. Oh, what's it? Oh, it said determine the STP volume of sulfur hexafluoride that will be produced from the reaction of 20 kilograms of sulfur, and then it gives us an equation.
so STP volume of
25 of sulfur hexafluoride. So SF6.
okay.
When you have 25 kilograms of sulfur. And then the equation is S as a liquid plus 3F2 as a gas gives you SF6 as a gas.
Okay, so you have 25 kilograms of sulfur.
Yeah.
And so you have S
Plus 3F2 gives you yields SF6.
Okay. And they want the STP volume.
Yeah.
And so this is easy. Okay. So let's see. At STP, standard temperature and pressure, we have PV equals nRT. Is that correct?
Mm-hmm.
Okay. So this here is molar volume. Is that correct? Okay.
Yeah.
So we know that molar volume at STP is always going to be the same. Depending on how you calculate it, which day you calculate it, it's either 22.4 liters per mole or 22.7 liters per mole. Okay, so if we know that we have 25 grams of sulfur, 25 kilograms, kg.
Mm-hmm.
So if I want to change that to moles, how would I do that?
You
Would
get
you
the
have to
molar mass of sulfur.
Would you have to convert to grams first and then do the grams per mole?
Well, you could keep it in kilograms, but
Oh,
I guess
that's
it'd
true.
be full.
Yeah. No, we don't have to.
Okay. So what is that? You said 32? Is that right? Kilograms per kilomole?
Yes.
I did show you that shortcut, didn't I?
Mm-hmm.
You were
Yeah,
that
then-
class, if I remember correctly.
Yeah, and then the kilos cancel out.
Okay, that's right. Okay. Boy, you guys are getting a lot of love. They're like, when do they want it?
When can we have it?
Okay, let's see. So then that gives me, and that's of sulfur, right? So what is the Momo ratio of sulfur to sulfur hexafluoride?
So a 1-to-1.
It's 1 to 1, right? So 1 kilomole so 1 kilomole S. So let's do that math. So would an evening one be good, like at 4 or 5, something like that?
Yeah, that would be great.
Okay. And for a morning one?
This meeting.
Okay. So then, if I want to know the volume, then I can go 22.7 kiloliters over kilomoles. And then we can start off with that 0.78. Multiply it across, and then you'll get your answer. Times 22.7.
Yeah, then you get 17.7 kiloliters.
Okay. Piece of cake?
After you explained it, yeah.
It's not supposed to be after. You're like, oh yeah, that's right, PV equals nRT, right?